Hi everyone, welcome to this lecture. So in this lecture, we will discuss the evaluation metrics for regression. We will see how to evaluate the performance of regression. Since we have learned least square method about the regression, and least square method is used to find the optimal values of weights and bias, now it's time to evaluate the performance of a regression. So these are the three commonly used metrics for evaluating the performance of regression. That is root mean square error, RMSE, mean absolute error, also known as MAE, and R square value. So the first is root mean square error. If we see the name root mean square error, so error is the last word. It means this will be performed first. That is, first we calculate the error, then we will square the error, then we will take the mean of square error, and finally we will take the square root of mean square error. So if we see the equation, first we have calculate the value of error, which is the difference between the target value and the predicted value. Then we square the error. After that, we are calculating the mean of a square error. So here we are adding the square error, and then we are dividing with the total number of samples. So here n is the total number of sample in a data set. So by adding the square error and dividing with the total number of samples, we are calculating the mean of the square error. So the final step, if you can see, is to take the square root of the mean square error. So what root mean square error tell us? So root mean square error tell us how far apart the predicted values are from the observed value in the data set. Since this is an error, therefore a lower RMSE is better for a better performance of a model. Now, how much lower is the value of RMSE, whether it should be a 0, 10, 100 or 1000? So basically RMSE value depends upon the value of target variable in our data set. So if our target values are in millions and our RMSE value is in 1000, suppose we have the range of Y in millions, and Y represents the housing price in a data set, and it is 1 million, 2 million or 1.5 million. So if Y is in millions and RMSE is in 1000, it means this is a very good value of RMSE because it is more than 100 times less than the target values. So whenever we calculate the root mean square error for a particular problem of a regression, we have to verify it, or we have to compare it with the target value. So if it is 10 times or 100 times or more less than the target value, then it is a good value. On the other hand, if the target values are in 100, 200, 300, in that case, it should be very low. It should be in tens. So whenever we calculate RMSE, it should be at least 10 times less than the target values of the data set. And when we compare them, then we will decide the performance of regression model. So there is no fixed lower or minimum value of RMSE. We have to compare it with the target values. The next matrix is mean absolute error. So we can see that the error is the difference between the observed value, the target value, and the predicted value. And here we are calculating the absolute value of error. And after calculating the absolute value, this is the mod. Mod represent the absolute value of the error. And after calculating the absolute value, we are calculating the mean of the absolute error. Now, this is also the error value, and we want to minimize it, and we want a minimum value of this error. Again, this value will be compared with the value of targets in our dataset, as I explained for root mean square error value. So if our targets are in million and this value is in 1000, then it will be a good mean absolute error value. The next value is R square value. Now, R square is not an error. It is a matrix which tell us how much there is a linear relationship between the independent variable and dependent variable. So we know that the definition of regression, or especially the linear regression, is to establish the linear relationship between the X, that is the feature, and between the Y, that is the target. So in that case, R square will tell us how much good is the linear relationship developed by a model between the independent variable and the dependent variable. So the range is from 0 to 1. So it is independent of the value of the y, as it was the case in root mean square error and mean absolute error. So here the range is between 0 and 1. So in that case, if the value is 1, it means it is a very good model. And if a value is 0, this is not a good value for a model. So we need a higher value of R2, and higher value is 1 or close to 1. Now let's understand this. So basically it is 1 minus to the ratio of these two quantities. So this is sum of square error. You can see that sum of square error, and this is sum of total error. So it is the ratio of both these two quantities. So this is our sum of square error. You can see that this is our error. We are squaring it and we are taking the sum. So that quantity is sum of square error. So this is sum of the total error. In that case, we subtracting the mean value of our target variables from each target value, and then we are taking the sum. So the requirement is that this value, that is SSE value, should be very small because it is a sum of square error. So if it is close to 0, or ideally if it is 0, then it will make this ratio equals to 0. So if this value is 0, this ratio will be 0. So in order to avoid 0, we subtract this from a 1. So this concept of R square is same concept, which is that of a correlation, that the value of R square tell us how much correlation is present between the independent variable and the dependent variable, or between the target values or our features. That's why its value ranges from 0 to 1. R square may be negative in some of the cases. That is, if our predicted value is very, very far away from the target value, so this term will be very large. When this term is large, then the denominator term, we will get the value greater than 1 for this ratio. If we get the value greater than 1 for this ratio, and if we subtract it from 1, we will get a negative value. So a negative value is not a good thing if we are getting for our prediction model. It means our prediction model is bad and we need to throw that model, because there are very less chance to improve the model if we are getting a negative value of R square. So we see that the R square is not an error for any of the data set, whatever be the range of y, the value of R square should be between 0 and 1. So 1 is the ideal value. So we need a value of R square close to 1 if we want to fit a good model on our data set. So in this lecture, we learn about 3 important metrics of regression. We learn about 3 important metrics to evaluate the performance of regression. These are RMSE, root mean square error, mean absolute error, and R square value. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture.